So hello everyone. Today HubLE brings us to the Bone Lab in Dresden, where I have the opportunity to meet two talented researchers. And the reason why we are here is that these young ladies have published this great study in the first issue of the new Nature Metabolism journal. So welcome Ulrike and Martina.
Hi.
Thank you for having you here. Can you please introduce yourself to the audience?
Yes, hi, my name is Martina Rauner and I'm a professor for molecular bone biology in Dresden, and I also head the Bone Lab together with Lorenz Hofbauer.
I'm Ulrike Baschant and I'm a senior postdoc in the Bone Lab and I'm a trained biochemist.
Okay, so can you tell us what are your research interests?
Yeah, my interests just evolve around bone in general and its interactions with other organ systems.
So I'm also interested in bone biology and I'm mainly interested in osteoimmunology and osteohematology.
Okay, so when we look at your study, can you tell me what is the most interesting finding of your study?
So the main finding of our study is that the iron regulator transferrin receptor 2 is also regulating bone homeostasis. And the transferrin receptor 2 is binding BMPs either as a receptor or as a co-receptor together with other ligands.
Okay. And so what prompted you to study the role of the transferrin receptor 2 in bone homeostasis?
So originally we were interested to look at the effect of iron overload on bone homeostasis, so we just by serendipity chose the TFR2 knockout mouse because that is iron overloaded. And as opposed to what you would have expected that they have a low bone mass, it turned out that they had a high bone mass phenotype, and that's practically what rose our interest and where we said, okay, here we have to dig deeper.
Okay. So, and you as a like experienced researchers, what was for yourself the most exciting fact during your study, the most exciting finding?
I think that one of the most exciting moments was when we discovered that TFR2 actually binds BMP ligands with the surface plasmon resonance analysis. Those were the first ones, and that was a very exciting moment when we realized that TFR2 might not only play a role in bone biology via BMP signaling, but it also opened the new avenue in liver, because we thought that could also be a new mechanism of how TFR2 senses iron in the liver, so that was very exciting.
Okay.
So for me the most exciting part was when we discovered that the TFR2 is also binding BMPs very efficiently in vivo. So we subjected the TFR2 extracellular domain to a mouse model of heterotopic ossification, and we saw that it very efficiently reduces the ossification.
Okay. So when I look at this, I think that there is also clinical relevance. Can you comment on that?
Yeah, of course, this is the clinical relevance of our study. So the heterotopic ossification is a hallmark of, for example, joint replacement surgeries, and it's also a characteristic feature of a rare genetic disorder, the FOP.
Okay. So I think our audience is also interested in how they know how hard it can be to bring such a big story, a big study to the end and to publish in Nature Metabolism. So can you maybe give us a general recommendation? What's key to the success of such a project, maybe to the audience as well?
Yeah, I think first of all, I guess you have to have an interesting finding that's worthwhile, really opening up new avenues in research. Like in our case, I think the TFR2 connected liver to bone, so I think that was an interesting finding, worthwhile digging deeper. And the other thing, I guess, is perseverance and hard work.
So for me, the most important skill that I developed was patience, and to believe that it's sometimes worth to wait for the big fish.
Okay, and can you tell me, are there any new skills you have developed during that long time?
Well, I think since it was one of the first times that we wrote a paper for a bigger journal, you have a very limited word count, so you really have to make every word count that you write down and get the message across. I think the other interesting thing that we learned is how to do a patent application. Since we have our finding that might be of clinical relevance, we also patented this invention. And that's also quite intriguing to see how to develop those kind of things where you have to think more in terms of economy and also clinical application.
Okay. So my last question would focus on the future. What is your next study you want to work on?
Yeah, I think the next step for us is to really look at the region where the BMPs bind within the TFR2 extracellular domain, because it's huge. So we hope by identifying the exact regions that we can make smaller constructs that still have a more specific binding potential for certain BMPs, and that way we hope that we can also have more targeted therapies.
Okay.
Yeah.
So Martina and Ulrike, let me thank you for this nice interview.
Thank you.
And for the audience, last but not least, the link to the publication you find below the video. So read it, enjoy it, and spread it. Goodbye.
Bye.